What's going on, everybody? We are doing something a little abnormal today. So, this is the part that we're working with, that I am trying to recreate. The kicker to this is I have one. I've reached out to the person that used to make these and they're not responding. They no longer sell them. Whoever was selling them doesn't sell anything. So it's like they just, I think it was some like private guy that engineered it, built it, sold a bunch, and then just stopped. Um, so I want to create a version of this that does basically the same thing as what this does. That's the backstory of what I'm trying to do. I'm not trying to steal the guy's idea. I just want to like create and try to get these out there because the RC racers need this product in my opinion. Um, does it mean it's right or wrong? I don't know. There's no patent on it, so I just know that there's a market for it. There's a need, and I am intrigued in learning these things. So, first things first, I had to identify what component is on this board. So let me show you what we're working with. Um, Trying to find you a good picture of what one looks like. Okay. This is what we're dealing with. This is the actual component zoomed in. Let's snip this. So we have a good base reference to work with. So there we go. Can I zoom in on this? I can. So the question is, what is what? That's kind of where this turns into a disaster, because I know what some of this is, but some of this I don't know, which is what I have to try to figure out today. With that being said, who in the world is blowing me up? So, I have a base understanding of what we're looking at and what we're trying to accomplish. But that's kind of where things get confusing, is because, like I said, I have a lot of it figured out. So, first things first, I think I want to print this on my own PCB board and kind of go from there. So, I had to identify what feeds what. Um, then the other caveat is because I don't know a lot, I also don't know so easy EDA. I had to create a schematic. And I want to upload file. So this is the file import. So this is the physical schematic of what we're dealing with. Why is this not letting me move all of that at once? Edit. Because I want to move. Like, this is the part that I don't get, because I don't have enough experience with electrical stuff to understand how all this works. And I would like to move all of this. Wait a minute. What? Undo. So if I grab that, can I just drag it all? I can, but it didn't, for some reason, it didn't grab that. I'm trying to put this in an order so I understand what I'm looking at. So that's going to go down here. So that's the LED. That's the infrared. Nope. That's going to go somewhere up there. I'm going to confuse the shit out of myself with this. Okay. Like this. What is... I don't know. I don't understand what some of this is. That's my button. So I know what that is. So that's... I think. Okay, I'm getting all kinds of confused. I guess first things first. I don't know. I'm all over the board. I don't understand what I'm doing. I'm over my head. But let's tinker, see if we can't learn something together. Maybe somebody will come in, chime in, and help. Because I am way, 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 way above my level of, what's the word I'm looking for? Comfort level. So I bought a inexpensive oscilloscope, and I need to figure out the frequency of this timing crystal. And I've never used an oscilloscope in my life. So this is a learning curve for me and probably anybody else that might be watching, because my normal clientele of people that watch my stuff, which is nobody, by the way, definitely is not an electrical engineer. So I am up a creek so far that I can't even swim. So that's kind of what we're doing today. I need I need voltage is what I'm going to need. So I'm going to need to hook this guy up. I'm positive of that to get the levels off of this chipset. And this is the oscilloscope that I bought. Again, have no clue what the fuck I'm doing. We'll figure it out. I'm going to need... What am I going to need? I'm trying to think how I want to do this. I'm going to need a 6-volt power source, and the easiest, fastest, simplest way that I know of doing it is going to be my RC car. Because that's what this is for. Okay. I'm going to disconnect the fan, because if not, this thing's going to get loud. And it's going to be obnoxious. And I'm going to disconnect that transponder because I don't need 2 of them running at the same time. This is going to go in like so. Honestly, it doesn't need to even run. Steering servo. I can disconnect you because it doesn't need to be on. Okay. There we go. So now I have the device powered on. Get this over here. That does not need to be on either. The problem is I don't know if I can get you guys close enough to see. I bought a microscope, but it's not here yet. So what we're working on is this guy. And then that guy. There we go. Okay, so turn this on. It's on auto. How do I check the frequency of this crystal on what it's operating on? I'm assuming pin 1 and 3, which would be the bottom left and the top right corner, is the correct pins. But I don't know. I don't even know how to attach. How do I attach to that with this? Because that's a ground. That's a lead for a wire. That's not going to work, but the probe might. And then I have this lead, which is positive and a negative. I don't know if that's going to work either. So if I ground this out to ground, I should get something out of that pin. Nope. Well, that guy. Nope. Okay. Nothing there. No. No. Why did it it just shut off? No, that doesn't work either. Okay. I'm confused. Wheel function? Okay. Yep. I'm already lost. How? Check frequency of timing crystal. Using a oscilloscope with a low resistance, a 10-time probe to observe oscillation or a frequency counter. This is high precision. Okay, so it needs to be 10 times, not 1x. So I was on the right mode. Okay.
Protect your family's dreams under our roof. American Family Insurance. Planet Fitness. We're all strong on this planet.
One more, everybody.
So we're at 10. Watch the, let me zoom in for you. Crystal. So first of all, oscilloscope, this is a function generator. Now they share the same ground. So they know as a reference what 0 is. Now we're going to take our crystal. Crystals are not polarized, so it doesn't matter which way you do this. Clip one side of the function generator. Clip one side to the oscilloscope. So it is now in series with the function generator and the oscilloscope. And I'm just going to lay it down there. We don't need to touch it anymore. So there's our function generator. There's our oscilloscope. Let me shut this stupid light off. Okay.
I'm already lost.
Protect your dream home under our roof. American Family Insurance. Enjoy 24-hour access at most Planet Fitness clubs. $1 down, $15 a month. Deal ends February 27th.
Hello, and welcome back. Today, I want to talk about crystal oscillators. This clock out will either output directly the frequency of the oscillator, or it will output some sort of submultiple frequency. And a similar approach can be used in something like a microcontroller. Just how well the oscillator is working, by using the clock out pin. Now, to perform the measurement, I have an SDG 1062 frequency generator from SIG. I already made frequency, but it's a so to keep in mind, of course, is the so what I have here is a different board. It's built around the PCM2902 USB audio codec, and it runs on a 12 MHz crystal. And this IC does not provide a dedicated pin to measure the frequency of the oscillator. Now you can use proper near-field probes, but for this measurement, I found that you can get quite good results, even with a bit of coax that has a bit of the central line unshielded. So right now the board is running, and if I bring my coax close to the oscillator.
Okay. Even more confused. Let me go check on the dogs real fast. Hold on, guys. Okay. I don't. I don't. I don't get why. Everything on this board is I don't know. Okay, let's see if we can't figure this out. So it does something. So I've confirmed that I'm getting something when I hit positive negative. So that's at least a start. Okay. Auto. Yeah, I'm I'm lost. But that don't take much. There's something. I don't know what I'm looking at. Hmm. I'm drawing a blank. How did I lose it? I'm confused. I don't I don't understand how I lost it. Oh, I wish I knew somebody that was an electrical engineer. This would make this flow much easier. Hmm. Connect the oscillator to your computer using a Type-C data line. Click on the U disk on your computer. Open photo. View the save waveform. Download the waveform to computer to easy organize and analyze. Okay. It's kind of cool. Huh. I mean, it does a lot. I just don't know what I'm doing with it all. Not what I wanted to do. How? Hook one of the crystal resonator terminals using one. If your goal is to measure the frequency, the best is to configure one of the MCU pins as a clock output and probe that pin. What? Microprocessor has two pins. One is an output that drives the crystal, and the other is an input that connect the oscillator probe to the output. This will change the frequency a bit, especially if there's no series resistors or crystals, but this will be close enough within the ability to scope to measure it. Okay, well that still doesn't tell me what's the output. What's the out? What side is the output? That's my question. So that's saved. Let's try throwing this on the computer real quick. Do I not have USB-C plugged into this guy? I can't see. Yeah, I do. This guy. Well, that's an HDMI cord. I mean, it'll work, I guess. Where did the little USB-C cable go? That came with it. There it is. Okay, I'm done.